for this chart, you have to remember so that you know where is the direction of it. And this one is just for info, right? I won't test you anything on this because it's not a fact. But this is just to appreciate that hydraulics can be used to do so much things on the plane. Now, why hydraulic? Because it's light in weight, less fuel burn, minimum maintenance requirement. Yes, this system is very reliable and aircraft is keep flying. That's very important. If it keeps falling, then forget it. Right, simple to inspect. Usually hydraulics are dyed, and when it is leaking, you can see. And ease of installation, components spoil, just change. Life goes on very fast. Now, Pascal law is what we learned. If I ask you on simple incorporation question, it's going to be at only one step. Right? Makes sense, right? Cannot be this question asked, then you're all. Anyway, the question is going to be jumbled up anyway. How do you do that? Now, fundamentals of law. Pumps create flow, no pressure. Don't go outside, go and buy one pump. Hey, from the vendor, I want pressure 5,000 watt. They look at you, what are you talking? Right? Don't make yourself like you know. It's the flow that we are talking about, not pressure. Now, resistance to flow creates pressure. Flow determines the actuating speed, and pressure determines the force. Very important. If your landing gear is so heavy, you got no pressure, then how to raise the gear? Ask the co-pilot, go down and push. Right, calm. Okay, next. You come to this card. You guys must be experts. If no expert, you still hearing me like that means I'm very worried. Now, in the experiment where Mr. Roger has to demonstrate to you, right, we have this what we call the open center selector bar. Why we know because this is going to be a C shape. Now, in your pump, constant displacement pump, in that experiment, we have a pressure relief valve, and then relief valve, and goes back to the reservoir. Now, first of all, first question, how do you know this guy is a 4-way 3-position valve? Because you can position 1, 2, and 3. Remember the lever, there are 3 positions. If you can't remember the 3 positions, tell me how many squares are there? 3. Sorry, some of them look like rectangle, but 3 squares. Now, how many ways? There's 1, 2, 3, 4. So it's 4-way, 3-position selector valve. This is the only one that I share with you so far. There's no 2-way, 1-way, no. I think 4-way, 3-position. Now, this selector valve. Now, if you remember your experiment, when we switch on the constant displacement pump, what happened? The flow went out immediately. So the gauge show how much? 12 bar. And you set this as 50 bar. Alright? Now, when it goes up from here at 12 bar, it tells you that it did not go through the relief valve because this one is easier path. So that's why this resistant. You guys go home, same thing one. Like me, like that, last time as a student. You go home, put your bag, your mom say, how's your day? Sister need to study. You put the book on the table, you go and, on the study table, go and bathe, you come back, what you do? You see the bed, you sleep. Right? Okay, that's how it is. Because that one got least resistance, no resistance, just stick only. Then stick. When they see exam, then you get very stressed. Alright? Some words that you all must remember. Okay? When the fluid is going out from here, we call this you are unloading fluid from the selector valve. If I do extension, eventually the resistance reached at full extension, what is the value? 50. So the fluid went out to the reservoir. In this case, we use the word relief. Be careful how my MSc asks you. Okay, only when the fluid goes out from the relief valve, we call relief. All else we call it unload. Now, chapter 2. Now, in your hydraulic fluid, we must engineer it so that it is able to withstand different temperatures and punishment from the environment. So we must put additives in. So when you do this, you must have viscosity. That's what you can accept, chemical stability, flex point, and fire point. Why? Now, if hydraulic piping go round in the engine, around the vicinity of the engine, one of the pipe bursts. When the pipe bursts, the hydraulic fluid will hit the engine bay. Engine surfaces, what is the temperature? 800 over degrees Celsius or not higher. Will it catch fire? Yes, if the condition is right. Now, how about viscosity? When you choose a fluid, now you got so many fluids, you choose one, what you want to use for your application. Will you choose a high VI or a low VI? You must choose a high VI because the gradient is smaller and the viscosity difference over the temperature is also smaller. So that's what we want to achieve, right? If you go for low VI, when you fly so high, you know what happened to your fluid? Become honey. Become honey, then that's it already. Your actuator can't extend or push. Okay, there are 3 types of hydraulic fluids, alright, over here. As mentioned, if under the correct environment, all of them will catch fire.
Nice.
Definitely. But this is the best. Extremely good fire resistance which is used on the commercial aircraft. And it's also very hazardous to our hands. Right, so please wear your PPE. Right? Okay, I'll wear your PPE. Anyway, doesn't mean that one or others also. Wait. What the frick? Okay, right, number 3. Now, reservoirs, we have 2 types. Okay, first of all, we talk about the function. The reservoir must ensure that you top it up such that it's the correct level. Now, you know that when the air pilot comes over to the aircraft, these are the things that they have to check. Reservoir is the correct level, right? And before he takes the aircraft, if not, he won't sign it off. Now, next is the reservoir must take more fluid to anticipate any leakage. Now, for your information, hydraulic has so many pipings in the plane that is bound to have some leaks. But the leaks is considered acceptable, so the aircraft can survive for the next 17 hours if the flight needs to be that long. So when there is a leak, the reservoir level is already there, right? But if it's quite drastic, you need to go and investigate, and hopefully it leaks up from somewhere. The color dye IC must be there, right? Now, to allow fluid to cool, yes, because when it comes back, you mix with the cold and the hot, then the temperature is able to manage expansion. Now, why? Fluid at very high temperature will lose its properties. Same thing, right? If I make you all stress so much, you say, sir, I don't want to study. But should be able to lah, alright? Okay, there are 2 types of reservoir, non-pressurized and pressurized. Okay, non-pressurized means what? The top here, there's no pressure, right? So, in the pressurized one, it's used to do the fierce maneuver. Can I use your bottle? Thank you. Give me 1 half. Since you mentioned that, I'm -1. No lah, joking lah. So, in the reservoir, unpressurized reservoir, pressurized reservoir, there will be an agent. Now, over here is where you supply your fluid to your pump. So, in the non-pressurized one, no issue. But the problem is when you go into inverted flight, what happens? What happens to the supply to the reservoir, to the pump? Air. Then run air. Then your actuator run air. Okay, cannot. So, cavitation. So, what we are trying to achieve is we also want to reduce cavitations regardless, whether it's non-pressurized or pressurized, by ensuring that reservoirs are usually placed at a higher height as compared to the pump on the aircraft itself. Now, even for our reservoirs in our HDD water tank, is also at the rooftop. Okay, it's not to prevent cavitation, to reduce cavitation in our HDD water. It's more to ensure there's a gravity to you, then you open your water, you feel very strong supply. Now, so for pressurize it, they will pressurize it. What happened? When you pressurize this area, the fighters will do inverted flight. Then the fluid must maintain to push up and supply to the pump. Then you won't have any cavitation or suddenly the actuator to push. Imagine you turn left, then you turn left inverted, then that's the last position. That's the last position. Then you say, never mind, landing gear now. How to landing gear now? I don't know. I never tried before. I think cannot. Don't ask me whether possible or not. Go and check for yourself. Alright? Okay, so understand pressurized and not pressurized. Next is to tell you that there are some variables and fees to do this. What is this? Very simple. You always to take eat prata and then you usually order what? The teh tarik, right? You pull the tea, uncle pull, and ensuring that there is enough foam, then they pass to you. That means you got tarik it. Now, when the foam there, when you drink, do you think you drink more air or you drink more liquid? Air. Correct. So, when the fluid goes back in from the return, if you go in and it starts to swell and whatever, right? What happens to the fluid? There's a lot of air. There's foam, it goes into your pump, my pump suffers more cavitation. Right, so this is the reason why that is the reason for that. Now, pressurized reservoir, we have two types. We have used the system hydraulic pressure to help us to press this guy up. Else we use bleed air. Now, you'll be surprised, sometimes we even use bleed air to pressurize the reservoir. Right? Not all aircraft has it, but for fighters and for fighter aircraft, they use bleed air to pressurize the fuel tanks. Okay, just for info. One thing I want you to take away is this. Whenever you pressurize this system, when you want to remove any piping, do you depressurize? Yes. Must you depressurize? When you want to remove any piping, because it's already pressurized after the flight, do you depressurize it? Yes. You have to. You don't depressurize, you open, all over the body. Okay? Water parade. I've seen for a friend who, because of this air pressure, after that he fainted. Yeah, no joke. Okay, cavitation. Cavitation, you have to understand the first statement. Cavitation occurs when the local pressure is lower than the vapor pressure. What does it mean? As the water goes through here to a smaller section, air bubbles will be formed. These bubbles are air bubbles where after that it becomes the bubbles become gone already. Okay. Now I use this to explain by balloons. Now if you are strong enough, a balloon inflated, you go and press it and you take it first. Right? At one point you also a bit scared, right? But the air escapes. So there is some forces to it. So this is what we call, in this case, microjets. Now these microjets, when there's a force coming out from it, it actually means that it will start to hit the metal surfaces in the pump. Now it's as if like you take a hammer and a nail to hit the metal surface. You hit one time, one bubble hit one time, two bubbles hit two times, 3, 4, 5. What happens to the material? Start to get thinner and thinner and thinner, and then it fails. Right. So cavitation cannot be prevented, but only can be reduced. One of the ways is to ensure your reservoir is always installed higher than the pump. In our water tank, in our HDB, at the top. Right? So it's about the same thing. Okay, pumps, we have these 4 ways. There is an emergency one where, let's say all your engine shuts down, your hydraulic pump is supposed to be installed on the SSC gearbox, right? So this guy will come out, to turn, then some generators will turn. Right? Now just to share, of all the pumps that we studied so far, the piston type is always able to give us higher pressure as compared to the others. Right? That's also the reason why they use this concept on the variable displacement pump. Okay? Now let's come back to this. Now constant displacement pump, they always have a graph of such. What does this mean if you forget in the lab? If you have the resistance, it will build up the pressure and it will cause an explosion. So in this experiment, what we did, we put a relief valve there so that the resistance will build up. However, relief valve is not supposed to be used to regulate the pressure demand of the actuator. So the only way is actually to install a pressure relief valve. Okay? The pressure relief valve, what is the pressure setting? I just throw one value, 25 plus or minus 5 bar. This is the pressure that is needed in my system. This one is the same as your back valve, your output valve. The same thing. It will regulate the pressure for you. Now, if I say this is a closed center selector valve, the moment you switch on the pump, where does the fluid go? What will happen to resistance? Maximum, right? So you must relieve the pressure, right? Or remove this pressure. The only way to remove the pressure is to remove the fluid. To remove the fluid, where did you go? 1 or 2? One first, correct. Because the pressure is lower. Because always go through this resistance, right? We go to the bed, we don't go to the hook. Right? So that's what it means. And if the fluid goes out from the pressure regulator valve, we also use the word of unknown. Follow so far? So this statement is to tell you that constant displacement pump, you must have a pressure regulator or unloading valve. If not, you're asking for trouble. Because first, you cannot control the demand. Second, you don't have this. Let's say you don't have relief valve, you don't have this, the system will explode. Alright, so please read the question properly. Okay? Variable displacement pump, okay, I just draw the center. This is the flow center, variable displacement pump. Okay, variable displacement pump works in a different manner. It has a pressure regulator function inside here. It has a PRV inside here. So let's say I set the real aircraft pressure 3000 plus or minus 50 psi. So the higher limit is what? 3050, the lower limit is 2950, correct? Alright, so if I have a variable displacement pump and switch it on, there will be no explosion because it has a pressure regulator valve function inside. So from the chart graph here, it already tells you that this is the exact 3000 that you are trying to achieve. And how do they achieve it? They use a source plate. This is your dry shaft. Two different scenarios. If it's less than 90, what does it mean? That means the pressure is too low. So what will be the pressure here? 2950. That means I must start to push more fluid to my customer. If I'm at 90, means it is 3050. In this case, what is happening? It's unloading. Right now. So that's what it is. Okay? Last but not least, if you allow the system to only have a variable displacement pump, there is no second line of defense, dangerous. Remember, your cabin pressurization has an outflow valve and a safety valve. So I must be a bit careful. I put one more relief valve here, and the setting is 3500 psi. This is the value and how the aircraft is designed for C-130 and F-16 safety. So they only have a variable displacement pump and relief valve. Voila, I can go with it. Okay? Okay? Now for filter unit, right? It consists of a house, bowl, filter element. The filter element is this one. It can be made of paper, it can be made of wire glass, a bypass relief valve, and an indicator. Now this bypass valve is the same as your water separator. I told you, if water separator becomes ice kacang, I must allow air to bypass into the cabin. If not, I got no air. Right? This one similar. Since this filter is supposed to filter debris, it's going to be very dirty. If it's clogged in flight 17 hours, you're 10 hours, now you're in the Pacific Ocean, then what do you do? Turn back. Eject. Cannot. I have to allow the contaminated fluid to go into my actuator. No choice. But once it lands, the ground crew must check this indicator. This indicator is red in color. It pop out, you check, pop out, it pops out. Then you better go and investigate. Don't reset. You reset, that means egg blur. Cannot. Okay, then if you reset, you tell me. Then my parents is not in the plane. Yeah. Okay. Next thing, I want you all to go back to understand this thing. Cage drain is to filter debris, but it's supposed to lubricate and cool your pump. What does it mean? You see your cage drain line here? When your pump is turning at high speed, it also must have cooling. The pressure is working. The piston, the small piston is based on cross plates. Around it, it must also be cool. So the reservoir also give him some fluid to cool it. While after cool, it must go back to the cage drain filter because it goes back to reservoir. Now the scary thing is when I have to change these filters based on the book requirement, we will always want to open this one first. You know why? When you open this one, you go and see inside, you see a lot of silver debris shaving. How does it look like? It's a bit like what ladies put on their glittering powder on their face. It's the same thing, but I never use it and rub on my skin, that's for sure. Right? But you see this, that means what? Where does it come from? Then we have to call warehouse to ask for a new pump. We need to replace this. So that's not what we really like now. So this is a real experience that we have gone through in my days there. So contamination can be abrasive particle, which is the one that I say I never rub it on my face. Yeah, non-abrasive is all the O-ring seal. Sometimes if we break a bit, tear a bit, then it may go into the system. system. Some you see, they talking about black color, what rubber, okay? Intermixing can be caused by what? This aircraft use A type. You go and service B type. It's the same thing. You go petrol kiosk, your car is petrol, you put diesel. Well done. Then you need to do flushing. Flushing means what? Take all the fluid out from the system, use the hydraulic card, put in all the from the can, pull out, take the new one, all flush it, go in and out. In and out, not one time, in and out, until you get the right result. The other possibility is flushing is also required when the book tells you to. For example, he said every 5 years or 1,200 hours, whichever comes first. Then you need to do. Why? Hydraulics will also start to lose its property along the way. Right? That's how it is. Defective fuel oil exchanger. Remember just now the diagram in part A I showed you? Okay. The hydraulic comes back to reduce the temperature, we use fuel. Because fuel is cold, because it's vented out in the atmosphere for the fuel tank by supply. So it reduces the temperature, but the fuel increase temperature. Good. So if these two guys is not supposed to mix, but inside crack out, the one of the pipe crack out, then you will GG. Alright? Yeah. Okay, last but not least is your hydraulic contamination check. Basically what we do is we take some sample of the hydraulic, we pour into this cup, there's a filter paper you're supposed to put in, then the filter paper will become will change color. Change color means either it's black, worse, brown, light brown, or white. So then it compared to a table. Then if it's pass, but if it fails, good luck flushing this. Alright? Yes, it should be fine. Now, type of flow control valves, we got a few here. Selector valves, we learned already, so let's go fast. Okay, for open center hydraulic power system is usually not used on our aircraft, but more towards the industry. Why? Selector valves arranged in series. What is the problem? That means, if let's say one actuator is for one system in my aircraft, this is flight control landing gear or gun. That means what? Only one system can work any one time. Can aircraft can work like that? Means in F-16, the gunnery also use hydraulic. So when you're flying, you use flight control, right? So you use flight control. Then you see, I want to show you, I press, no bullet come out. Because you only can use one system at one time. Clumsy, right? But that also explains that this is not what we want in our aircraft system. But we need to learn the difference. Alright? Second, there's no pressure when it's idling. Correct, right? Allow me to redraw this. Initially this was connected, right? You got 12 bar. No pressure increase. Alright? Last but not least, it's a smoother operation. Why? The moment you select to number 1 position, the actuator will extend, right? Then you will build from 12 to 50. So it's gradual increase. In APP, what we learned, Excel is can store and search, right? Later we talk about it. But there's a gradual pressure increase. So very good. So it's a smooth operation. Okay? So this is what it means. Check valves. What does check valve mean? Check valve means they only allow fluid in one direction. So if the whole class is here, there's 100 of you, right? Check valve says, once you leave this room, you cannot come back again. That's check valve. That's how it is. Orifice check valve is different. Orifice check valve means 100 of you can leave. We actually are fluid particles. Go up, come back 50. Okay, where on earth do we need this orifice check valve? Now for landing gear, when you just take off, you select landing gear up, right? The landing gear starts to retract. Do you need full fluid force? You need, right? 100, right? So that means for retraction, I need the orifice check valve to be orientated such that 100 of you go to the retract actuator to pull the gear up. Right? But how about extension? When we are extending, it's different. The door will open first. The door open already, then the landing gear will drop by gravity. So it's assisted by your hydraulic fluid as well. Now, if you allow 100 to go as well, the landing gear will extend with a very loud bang at the end. Boom! Then what happens to the structure? Example, every day you go home, you don't do that. Every day you go home, when you reach your room, go inside, you slam the door, boom! Your mom says, hey! Then you for 50 days, then one day you realize the last time you hit the door dropped. Because the structure cracked already because of you lah. Holding down. Same thing for landing gear. What if the landing gear on the 50th time the whole landing gear drop onto your house? HDB. Alright. So to restrict this, I use the word restrict is for the extension, we want to slow it down. We only want 50. 50 of you to go to the actuator to extend it. Because it's assisted actually. Enough for you. Okay? Okay, sequence valve, what you need to know is there are two types that we have gone through here, mechanical and pressure type. And this sequence valve, my explanation is on the landing gear. Now, landing gear is the gear will retract fully first before the door closes. And then if I want to extend, the door must fully open before the gear come down. It's the same thing for you, right? Today you go home, nobody at home, the door is closed, the gate is locked. Just go in. Can
Yes.
Sure, you should do that. You can't, you must open the gate, there's a sequence for you. Open the gate before you open the door. Same thing. I think for myself, the gear and the door close at the same time, move at the same time. The door was damaged. But usually sequence valves are quite reliable. So over here, the next few slides is just for you to appreciate how the sequence valve works. Okay, appreciate Okay. Next, priority valve. Now priority valve, we know that some of the systems are considered primary and secondary. In aviation, you always hear this primary and secondary here and there. What does it mean? Primary means it's the most important system for the aircraft when you fly. Secondary means don't have you also never mind. For example, for C-130, when you fly, let's say it's going for a parachute mission, they need to open the cargo door, the red line, they jump out, right? Let's say touch they fly halfway, the door cannot open. Never mind lah, never open, right? The pressure will drop lah, then you cannot move, but the red line come back, we jump from the door lah, whatever. But anyway, the point is, priority valves prioritize the pressure to what is in need. If it's lower in pressure, I don't have enough, then sorry, the cargo door doesn't open, never mind. Alright, that's how it is. Shuttle valve, related to landing gear, it allows only one system to operate at any one time. If hydraulic is working fine, the shuttle valve will allow the hydraulic to go through here. But what if my hydraulic pump fails? Then I need to bring down my gear. Finish. I must find a way, emergency way. Now in this way, what does it work is that you have a nitrogen fuel tank, air tank, is at 3000 psi. Alright? After that, when you activate this pneumatic air, you will push this shuttle valve to the left. Then the pressure goes to the landing gear. Where did it go? It goes to the door actuators. These door actuators can be extended by pressure, hydraulics or air. So if my hydraulic is down, I only have air. The air goes in and extends the door actuator. Once it extends, the door will open, right? Then the gear is coming down by what? Gravity. Remember? Without hydraulic also never mind, but we must ensure that it functions properly. That's why we have orifice check valve there. Alright, so that's what it means. Hydraulic fuse. Hydraulic fuse is nothing but your electrical plug. There is an electrical fuse as well. Okay, there's a thin wire. If there's any high surge, the wire will melt, and then that protects your appliances. Now, this hydraulic fuse is measured by flow rate. If there's a piping here, usually hydraulic fuse will be employed at somewhere at the engine bay area, where there are hot surfaces. So if let's say there's a pipe here, the pipe broke. Ask the class, what happened to the flow rate? Increase, right? When it increased, the fuse inside there are some springs. They know that the flow has increased to a certain limit, right? It will stop the fluid from leaking anymore. There are two reasons to it. First, if there's more leak to the area here, hydraulics at the right condition with the engine bay hot, it will catch fire. Another reason is to not allow any more leaks. Hopefully the reservoir has enough to supply some other systems. Alright, that's what we use. Okay, that's all. Chapter 5, 6, 6 or 5. Okay, just on time. Yeah, 39. Now, for your relief valves, okay, relief valves, you must understand a few things. Relief valve is like your cabin press. It's like a safety valve. Okay. It's set at higher pressure, which I already shown here to you. Now there is cracking pressure, full flow pressure, and pressure override. Now question for the class. Read the question properly. If I ask you, when will the relief valve start to open? Is it at 3005 preset or 3001 or lower than 3001? You all must go and find out. This is your homework. Right, cracking pressure. When will it start to unseat? Is it really at 50? Okay, go and do some homework. Must change battery must change. Where am I? Lost. Okay. For thermal relief valve, the word thermal already tell you it's got to do with temperature. Now, why thermal relief valve is here between these two? When I already have a system relief valve, why must I bother to have that? Now, very simple. This piping likely will be somewhere in the wheel well. When the aircraft starts to land, it will open, and then this piping will be exposed to the environment of the airport. Now, if at the correct temperature, higher temperature, the fluid will start to expand. Expand means it got no way out, it may cause the pipe to burst. So one way to resolve this is I will use a thermal relief valve to relieve the fluid over here. Then you may ask, instead of system relief valve, dead man, is he sleeping or what? No. Look at the selector valve at this position. It's not able to connect up to the system relief valve. Hence, thermal relief valve has to be employed. Right? Next thing I want you all to understand, in your MSD, you will see something called this is Mount Everest, this is your ground. Now I will use upstream and downstream word very, very commonly in the text. Right? Now, what about upstream and downstream? Let's go for a very simple system. Now, your upstream must be your what? Reservoir. The very first time. You get your water from your HDB water tank, right? That's where it comes from. Although you can argue, sir, sorry, from the Mariki reservoir. Right, we'll start from reservoir. What's next after the reservoir? Pump. What's after the pump? Selector valve. What's after the selector valve? In this case, maybe you put thermal relief valve. What's after thermal relief valve? Last but not least, infiltrator. Now, if I say, I ask the class a question, which one, who is the upstream of the selector valve? Upstream. Pump, right? Who is the downstream of your thermal relief valve? Upstream and downstream, this is like a river flow coming down, so this is upstream, downstream. If you have to buy a property, you definitely want to buy upstream, don't buy downstream. Because when I bathe here, the dirty water goes to number 2. If I bathe again, the what you get in the actuator, where it stays will be dirty. True lah, you go look at me like that, you go and check really, that's the case. The higher you are, the cleaner the water is. Okay? Pressure regulators, you already know, is supposed to control at a predetermined pressure. This side onwards, just appreciate and understand as much. Now, again, I will ask you the same thing. Question, you all better understand this. Understand this, you must understand it. At what pressure will my pressure regulator open? 3000, below 3000, or 3001. If you go through a calculation, you know the answer. I won't test you on this on the calculation, but if I ask you a question, it must be figured in. Understand? Huh? This one you already know already. Okay, closed center hydraulic system. The good thing, this is what we use on aircraft. First, the selector valves are designed in parallel. That means flight control, gun, and landing gear, I can operate at the same time. No problem. But that doesn't mean that you can abuse it. Give an example. I've seen it before. The pilot comes down and tell me my pressure gauge is fluctuating. From 1,000, 3,000 fluctuate. Then he comes down and tell me, I think your system got problem. Then I ask him, at what phase did this happen? Cruising, climbing, or descent? He says, just take off, climb. Then I ask him, what are you supposed to do? He said, throw the landing gear up, then keep the flaps off, retract the flaps off. Do you do it at the same time? Then suddenly they're very quiet. then the air crew suddenly just move away. Then I know, then they come back and say, yes, we did it. You know why? When you do both, you operate both systems at the same time, it will fluctuate. Because landing gear is very heavy, and your flaps is also very heavy, very demanding. So the pump may not have the capacity to give you the flow. Fluctuation is normal. In your flight manual, you're supposed to do one at a time. Then after that, then end of the day, we have to check out the aircraft. Wait 6 hours to do landing gear swing. Make sure it doesn't fluctuate. That's how it is. So my point is, the pump is also not designed to give you very big capacity. Right? They make sure they optimize it in terms of weight, and they tell you that please, landing gear first, fully retract, then do the flex. Don't do both at the same time. Right? Understand that? So it doesn't mean that it's unlimited. The pump is the strongest guy. Not fluid under pressure and pump operating, yes. When you switch on the variable displacement pump, what happens with this pressure? Instant pressure. Then your pressure available at the moment of notice. Correct, right? The moment your 3000 here, you select your actuator, immediately that will respond. This one there's a delay. This one got no delay. This is what we want. Okay, we shoot, we got the time, we shoot. This guy got delay, you press the button of the bullet, maybe the bullet take 1 second later, but then the airplane fire away. Finally. Okay, so this is just a repeat. Pressure reducing bar. Not all actuators require 2000. Sometimes we need lower. So if we use this reducing bar, quite understandable. If not, then I need to design another small pump to unnecessary gearbox. Waste it when you have no pipe. So it doesn't make sense. Okay. Next, indicating system. Your reservoir at low level. What does it mean? This reservoir quantity will be telling the pilot how much you have. If it leaks too much, then you have a low level code switch to warn you that the level in the reservoir is dangerously low. Okay? Pressure sensor, pressure switch. This one is 1 and 3, right? Okay, so it's supposed to show you 3000. And when will you install these two things? Outlet of the pump, for sure. Why warning? Why must there be a warning at the gauge? I think I shared with you before. Pilots have no time to look at all gauges. There are so many gauges on the plane. They only make sure that the warning is right in front of them. Whatever warning, then look at the gauge and respond accordingly. Alright? Remember cabin press also got warning, right? Then you also have another gauge of cabin altitude, right? But why must they look at this? You see this warning, then you respond. Okay? Temperature, we need to know the temperature going back to the reservoir, and it's usually installed on the return pipe. Return, then you need to know. If you put this guy at the pressure outlet, then what are you looking for? Surely very high, 3000 psi, right? Okay? Last chapter, we are design. Now, for your actuators, okay, remember, if they ask you in just one step, okay, in your quiz, in your lab quiz, B1, B2, there's a calculation where if you want to know the extension force, you need to use 5 big T squared over 4. But if it's retraction, you only know that the fluid touches the purple area. So you must use 5 big T squared minus 4 big T squared to find the purple area. Alright? Linear actuators, double acting we learned, single acting just to share, it means that there's a spring to retract it back to the original position. Now in my time, in my work, before they send this, after they service this actuator, before they send it to the warehouse for you to be used, they will cap this area so that no foreign objects or animals or insects will go inside and build their own family. Because in that case, if I've installed the aircraft, then they will restrict the extension stroke. So we need to do that. So one day at 2 AM, we have this to be replaced. We order from the warehouse. We install, it fails. It fails the operational check 2 times, 3 times. Then we didn't know why. Then at about 6 AM, then we realized because we forgot to remove this cap. Silly, But anyway, these are why I say you learn forever, So this one is probably 1 step at max. Now rotary actuators means what? The fluid goes in here or left or right. The rack will move left or right. The pinion will turn clockwise and anti-clockwise. Where will this be used? Your slats. Right? This one rotates clockwise and anti-clockwise. So it will move down and out on the leading edge. Right? This is an application. I'm done. Okay. So Again, as mentioned, I need to ensure that you understand that any pointers, any points that I did not go through doesn't mean that it's not important. But what I just mentioned to you are definitely some focus points that you need to look at. Okay? FAR, there will definitely be questions. So if you want to see whether how much time you have, then you go and study it. Right? That's the only thing. Okay?
Looking at this,
No, I don't think so. It's probably, I don't know, maybe they'll ask you like, just last one point. Chapter 1, for example, there's MMEL and MEL. So you must know what it is. That means to say when aircraft flies, they have a lot of redundancy system. For hydraulics, depending on aircraft, they may have A, B, C, D, 1, 2, 3, 4. So at any one point, there's only one system need to be used to operate the aircraft. So if A is down, B will take over. Now, who justify to you that when B fails again, C and D is still operating, can we still fly? So this is what we call minimal equipment list. So we must follow through accordingly. Okay, so probably there are some questions that will be there. Okay. And what other certification do you need if I'm doing it for the engine, say for aircraft system? A bit towards air law, I think. I don't think air law, but it's up to you. But I think just to make this clear to you guys, hey, first of all, hey, you guys in your TME class, a lot of people never do the quiz. You all make sure that you tell them. I sent out email already. Hey, those who have not received emails from me, that means you never do your quizzes on your lab. Hey, don't do quiz. The chance of reward is very high. I better warn you.